The Ferris wheel problem. A Ferris wheel with radius 2.5 meters makes one revolution every 12 seconds. It's 2 meters above the ground. Draw a graph that models the height of the Ferris wheel with respect to time, and write an equation of the function that models the height of the Ferris wheel with respect to time. To help us draw a graph that models the function, it's a good idea to draw a circle that looks like a Ferris wheel, and it will help us determine the maximum, the mean, and the minimum height values for your trip on the Ferris wheel. And secondly, it's a good idea to start with the period and the duration of time that helps you visualize how long a cycle lasts. It says 12 seconds, so let us work with the idea that the trip begins at 0 and ends 12 seconds later. So let's do that. Let us put the 12 seconds portion here, so you know that the ride is going to last 12 seconds. It also helps to note that the sine or cosine function that you choose to draw is going to have 5 key critical points, and you know that starting from 0 you're going to have a halfway point, and then a halfway or a quarter point, and then you have a 3/4 point and the 4th quarter point. So let's fill in the other values. 6 is the halfway point between 0 and 12, and if we look at the halfway point between 0 and 6, we have 3, and then the last point that we need to know is 9. So what you have is between 0 and 12, 1, 2, 3, 4, 5 key critical points that you're going to map out. Now let's find the 3 key critical height values for the Ferris wheel. We're told that we start 2 meters above the ground, so let's place 2 at the bottom of the ride, like so. We're told that the amplitude is 2.5. That means to go from here to the center of the wheel, we need to add another 2.5 meters. So let's do that. And it's 4.5. From the center of the wheel to the highest or the maximum point of the wheel, we add another 2.5, namely 7 meters. So now let's recap. We know that the bottom of the ride is 2 meters above the ground. We know that the mean is 4.5 meters above the ground, and we know that the maximum height of the Ferris wheel is 7 meters above the ground. We can also know that the amplitude is 2.5. We could have figured that out by taking the maximum value and subtracting the minimum value, which is 5, and then dividing it by 2, which is 2.5. To find the vertical displacement, that means how much the graph has been shifted from the initial point, you take the maximum of 7, add the minimum of 2, and that is 9, and then divide it by 2, which is 4.5, or the mean. So the amplitude is 2.5, and the vertical displacement is 4.5. Now let's look at the graph. So now let's plot our 5 key critical points and draw a smooth curve to connect them. So we start at time 0 at 2 meters above the ground. So let's plot our first key critical point, like so. We know at time 0 the height is 2 meters above the ground. And then as you move in this direction, your next key critical point 3 seconds later, or a quarter turn around the 12-second cycle, is going to be 4.5 meters above the ground. So the point 3, 4.5 is the next point that we have to plot. And then if you make a half turn around the 12-second cycle, you'll get to the highest point, which is a half turn or 6 seconds. So the next key critical point is going to be 6, 7. So let's plot that point like so. When you make a 3/4 turn around the 12-second cycle, that means you've made 9 seconds, but you also know that you're coming down back to the mean. So the next point is going to be 9 seconds or 3/4 of a turn, and you're back at 4.5 meters above the ground. And now finally, when you make one complete revolution, if you start at 2 meters above the ground and make one complete revolution 12 seconds later, you're going to be at the minimum value of 12. So the next point is 12, 2. And so thus, we have plotted our 5 key critical points. At time 0, you're 2 meters above the ground. A quarter turn later, or 3 seconds later, you're at the mean, 4.5. A half turn later, or 6 seconds, you're at the maximum. 3/4 of a turn later, or 9 seconds later, you're at 4.5. And then at the full complete cycle, or 12 seconds later, you're at 12. So now let's look at the curve for this particular function. And it should look something like this. So you can see very nicely and neatly that this connects all of our 5 key critical points, and we're ready to develop a function for this particular curve. Let's use this equation to find the equation of this sinusoidal curve. Please note that the cosine function would have started at the top and worked its way to the bottom and then gone back to the top. That is what the cosine function would have looked like. In this case, we don't have that. We have a reflection. So this is a reflection of this. So let's use the negative cosine function to indicate that. Then let's look at the amplitude. Let's look at the k value, the phase shift, and the vertical displacement to find our subsequent equation. So the maximum and minimum values are 7 and 2, so respectively you go 7 subtract 2 divided by 2, and that is 5 divided by 2, which is 2.5, the radius of the wheel, which was initially given to you. The k value, which is the 360 degrees divided by the period, is 360 divided by the length of one cycle, which is 12. And then we look at the phi, which is the phase shift. Did this horizontally move either left or right from where it should have began at the point 0? And in this case, it doesn't give a shift. It neither moves left or right, so the phi value is 0. Now let's look at the vertical displacement. You just take the maximum plus the minimum and divide by 2. So in this case, you go 7 plus 2, which is 9, and then divide by 2, which is 4.5. So now let's fill in these values to help you visualize what we've been saying all along. Again, 7 minus 2 divided by 2 is the amplitude. 360 divided by 12 is the k value, or the horizontal stretch or compression factor. The phi indicates the phase shift or horizontal translation left or right. In this case, there isn't any. And then the vertical displacement, which indicates how many units we moved up or down from the original starting point. And so when you simplify the math, what you should get is a final equation that looks something like this. F of x, or the height of the Ferris wheel with respect to time, is -1 times 2.5 cos of 360 degrees divided by 12 times x plus 4.5. You can simplify this further, but I will leave that as an exercise for the reader.